A rare double transit of an exoplanet was recently captured by multiple telescopes around the world. The event was so exciting that astronomers are struggling to come up with an explanation for it. And I have to admit, the more I think about this, the stranger it seems. So today, we are going to look at what happened and why this discovery is such a big deal. You know how the moon can pass between Earth and the sun to cause a solar eclipse? Well, in this image, it's not the moon, it's a massive Jupiter-like exoplanet passing between us and its star. That's a transit. You see, from our perspective here on Earth, the planet lined up perfectly in front of the star, which allowed scientists to capture this amazing image. Now, typically when a planet transits its star, it causes a slight dip in brightness as the planet casts a shadow on the star. This happens because no light can pass through the planet's incredibly dense atmosphere. But this time, something strange happened. After the first transit, the planet passed in front of its star a second time. And scientists have only witnessed this once before in 2006, when they observed an eclipse by the exoplanet system HD 209458. The recent double transit was captured by the Galileo Global Telescope Network and the La Silla Observatory in Chile. It occurred in the star system WASP 39, located 730 light-years away in the constellation of Leo. The star WASP 39 is very similar to our Sun, but it has a slightly higher surface temperature. And unlike our solar system, WASP 39 has two planets orbiting the star. The outer planet is extremely hot and gaseous, similar to Jupiter, Neptune, and Saturn. It orbits its star every 11 days, passing close enough to be in the habitable zone where liquid water could exist. But this planet isn't the focus of today's video. We're talking about the inner rocky planet called WASP 39b. It orbits the star every 7.1 days. Scientists already knew about this planet because in 2021, Webb captured the incredible image of it during a single transit. But what they didn't expect was that just 3 months later, the planet would pass in front of its star again. And that's what makes this event so special. During a double transit, the planet appears twice on the star. Scientists refer to the first transit as primary and the second one as secondary. During the primary transit, the planet completely covers the star. However, during the secondary transit, the planet's silhouette is inverted. It happens due to the way light reflects off the planet's atmosphere. But there's more to the story. Astronomers have been baffled by the fact that the planet's secondary transit lasted much longer than expected. It should have been over in less than 10 minutes, but instead, it lasted almost 11 hours. Why did it last so long? How can this happen? Well, this is where things get really interesting. Scientists believe that the secondary transit lasted so long because the planet doesn't have an atmosphere. In most cases, if a planet doesn't have an atmosphere, it won't have a secondary transit. Secondary transits occur when light reflects off the planet's atmosphere. But if the planet doesn't have an atmosphere, then no light will reflect and we won't see the planet at all. So how did scientists capture an image of WASP 39b's secondary transit? If it did, you won't have an atmosphere. Well, there are other factors at play here that we need to consider. One possibility is that the planet's surface has some sort of reflective material on it. Maybe there are clouds, or maybe it is covered in a reflective material that humans have undiscovered yet. But whatever it is, it's reflecting enough light for scientists to observe the planet's secondary transit. Another explanation is that there's something else going on here that we aren't aware of. Perhaps there's an object orbiting the planet that's casting a shadow on it. But if this were the case, wouldn't we have seen this during the primary transit? Actually, yes, we would have. But the object's gravity could be affecting the planet's orbit, causing it to line up perfectly with the star for the secondary transit. And this isn't the only strange thing about WASP 39b. According to research published in Astronomy and Astrophysics, the planet receives 11 times the amount of radiation compared to Earth. This level of radiation should have blown the planet's atmosphere away long ago, but somehow it still has one. It's possible that the atmosphere is being blown away, but at a slower rate than expected. Or maybe the atmosphere is being replenished by another source. These questions may never be answered. But here's the thing, as scientists continue to study WASP 39b, it may provide insights into exoplanets that could help us find life elsewhere in the universe. That's because scientists believe that WASP 39b could have a liquid water ocean, even though it receives 11 times the amount of radiation as Earth. To understand why, let me paint you a picture of Earth's atmosphere. Our planet is bombarded with radiation from the sun every day. If it weren't for our atmosphere, this radiation would destroy all life on Earth. But our atmosphere protects us. It absorbs and scatters radiation, keeping Earth habitable. However, if a planet like WASP 39b had an atmosphere like Earth's, the radiation from its star would tear it apart. So how could there still be a liquid water ocean? Well, according to research, there's a possibility that WASP 39b had a massive atmosphere early in its formation. It was likely blown away by the intense radiation from its star. But over billions of years, the atmosphere could have regenerated itself to a point where it could support liquid water. If that's true, then finding life on WASP 39b could revolutionize our understanding of astrobiology. You see, if there's liquid water on this planet, it means that there could be other planets out there with conditions suitable for life. Of course, all of this is speculation. We don't actually know if there's life on WASP 39b, but the fact that there could be is exciting enough. The discovery of the double transit was made possible by the Galileo Global Telescope Network. This network consists of several small telescopes spread across different continents. By combining their forces, they're able to achieve the same resolution as a much larger telescope. For example, if one telescope captures an image of a star, but it's too blurry to make out any details, the Galileo network can use multiple telescopes to combine the images together to create a clearer picture. This allows them to detect smaller objects that would be visible to a single telescope on its own. In the case of WASP 39b, the Galileo network was able to detect the secondary transit because of the high-resolution cameras on each telescope. They were also able to rule out other explanations for the phenomenon. For example, they looked at WASP 39b's radial velocity to make sure it wasn't orbiting two stars. They also used the Lucilla Observatory in Chile to track the star's brightness during the transit. This allowed them to confirm that the dip in brightness was caused by a single planet passing in front of the star. It's important to note that while WASP 39b is the second planet to exhibit this phenomenon, the first exoplanet to do so, HD 209458b, is still a bit of a mystery. Astronomers believe that it does have an atmosphere, but they're not exactly sure what it's made of. Some studies suggest that it could be similar to Earth's atmosphere, while others say it's more like the atmosphere of Jupiter. It's possible that WASP 39b's atmosphere is somewhere in between these two extremes. That's because HD 209458b and WASP 39b are very different planets. HD 209458b is about twice the size of Jupiter and has a mass that is almost twice as large. WASP 39b, on the other hand, is smaller and has a mass that's only slightly larger than Jupiter. As mentioned earlier, WASP 39b is also in the habitable zone of its star, while HD 209458b is too hot for life as we know it. Despite these differences, both planets exhibit the same atmospheric phenomenon during their transits. This suggests that there could be a connection between the two. Maybe WASP 39b will provide more clues. Now, as for the duration of the secondary transit, astronomers aren't exactly sure what's going on. It could be that WASP 39b doesn't have an atmosphere at all, but without further observation, it's impossible to say for sure. What's clear is that this phenomenon is extremely rare. That's why it's so exciting that we were able to capture it twice now. Each time gives us more data to analyze, and hopefully one day we'll be able to solve the puzzle. I hope you enjoyed learning about this mysterious astronomical phenomenon. If you want to keep learning about space, check out this video next. Thanks for watching.